So the reactions of halogen with the compounds, the more reactive halogen displaces the less reactive halogen from its compound. So if we have bromine, which is Br2, reacting with aqueous sodium iodide. So what will be the result if bromine is reacting with aqueous sodium iodide? So as we know, bromine is more reactive than iodine. So bromine will displace this iodine. As it will displace, so it will form sodium bromide because group I and group VII compound plus iodine molecule. Then we'll balance the equation. Yes, aqueous will be there because this is, so we'll balance the equation. We'll put two equation as balance. So state bromine is liquid at room temperature. We add to a solution of sodium iodide. This one will be aqueous and iodine is also aqueous. Group 1, 2, 3, they're compounds in a solid state, they are white solid. But if it is formed, dissolved in water, then it will be colorless. So if we have originally, what is the color change for the solution, if we ask? So we have sodium iodide, solution aqueous is there. So group 1, 2, 3, when they are soluble salt, they are colorless solution. So this will form a colorless solution. We are adding a bromine. Bromine is red brown in color, but the question is, what is the color change in the solution? So this will result when this reaction will occur. Bromine will displace this iodine. So as the bromine will displace this iodine, it will form sodium bromide. Sodium bromide is colorless. Sodium bromide, it is a colorless solution, but what happened? Because iodine is also formed, and iodine, when it is formed in an aqueous solution, it can have two possibilities. If it is too much iodine, then it will be brown. If it's small amount of iodine, then it will be yellow. So it can be yellow or brown acceptable. The same thing we will observe. And there's one more thing, iodine in the presence of the starch, if the solution, if we add starch to the final solution, it will turn blue black, because iodine is also a test to check the presence of the starch. You have studied this in bio, I guess. So if we add a starch to a final solution, it will turn to blue black. So iodine having different colors depending on the medium. So if iodine in the presence of the starch, the solution will turn blue black. Even it will not be yellow or brown. If we add a starch, it will turn blue black. Is it clear? And if I want to write an ionic equation, I will cancel out the common ion. So I will cancel out the common ion. Sodium is common. But why I'm not canceling iodine molecule? Because here is I2 and here is iodide ion. So molecule cannot be cancelled with ion. It should be ion both sides to cancel out. So that's why it does not cancel out. So when we write an ionic equation, it will be Br2 plus 2I minus 1 gives 2Br minus 1 plus I2. That is ionic equation for this reaction. Is it clear? The reactions of halogen with the compounds. So this is a simple test to identify whether we have more reactive halogen or less reactive halogen. So we can add, like example, if we have sodium iodide solution, we can add a bromine or we can add chlorine. If we observe a color change, it means that the halogen which we are adding is more reactive than the solution of that halogen. If there is no change, it means opposite, that the solution, the halogen which is present in the solution is more reactive. If in case of iodine, if it was bromine, then what you will observe, a bromine, like if we have sodium bromide aqueous and we bubble chlorine gas through the solution, so it will form sodium chloride because chlorine is more reactive plus bromine molecule. Aqueous gas, because it is formed in the solution, so it will form a red brown solution, because here this is colorless, this one is also colorless, but bromine, even in a liquid or bromine dissolve in water, it will be red brown. So solution will turn red brown, because if a colorless things mixed with a red brown substance, so what is the appearance, the resultant, the color is same. It might be paler or lighter in color, but it will be red brown. Yeah, orange is because red brown shows a darker or greater intensity. So if you write orange, that in practical that is orange in color, but acceptable red brown, orange is the right answer, is orange, because it turned lighter in because colorless thing mixed with a something which is darker in color, so it will become light, and light shade appear to be orange, so orange is also the right answer, as well as red brown is acceptable as well. Is it clear? Now some questions related to this halogen. Now some questions related to halogen. Halogen and the flame test as well. Um, Look, in this question, a substance X react with warm dilute hydrochloric acid, which produce a gas and decolorize acidified potassium manganate 7. The gas is sulfur dioxide, but this is, which test is this? Warm dilute hydrochloric acid is added and test the gas with potassium manganate. Which negative ion? I give you a hint. This test for negative ion. It is a test for not sulfate, sulfite. Sulfite is SO3. PHITE, I can write that, or I can also say SULFITE. Both spellings are correct. So this is a test for sulfite ion. Sulfite means SO3. Test for sulfate is barium nitrate, or adding a barium nitrate, or adding barium chloride. That's a test for sulfate. So this is a test for sulfite, so it means it contains a sulfite. And a substance X give a yellow flame. So yellow flame is for which alkali metal? It's for sodium. So the flame, using a flame, you identify it contains sodium, and using this test, you identify it is a sulfite. So what is the name of this compound? It is sodium sulfite. So D is the right answer. How I know this is a sulfite ion? When you check this test, warm dilute hydrochloric acid, this is a test for sulfite ion. If it gives a gas and that gas turned acidified potassium manganate 7, so this confirms that this salt contain a sulfite ion. So this is a simple test for sulfite ion, negative ion. And how I identify there's a sodium? From the flame test, I identify it's a sodium, so it is sodium sulfite. In the next question, which element is less reactive than other members of its group? Astatine, cesium, fluorine, rubidium. These are group 1 and this one is group 7. For group 1, as we go down the group, the reactivity increases. But for group 7, as we go down, the reactivity decreases. So astatine A is the right answer. Dilute sulfuric acid is added to two separate aqueous solutions X and Y. The observation: dilute sulfuric acid are added to solutions. The observation: solution X, it gives a white precipitate, and solution Y gives a bubble. So which row shows the ion present? Look, if we add sulfuric acid, H2SO4 is added, and as a result, we are getting a white precipitate. So why white precipitate is formed? It means the solution was having a barium ion, because barium ion mixed with sulfate ion, it will form barium sulfate, and barium sulfate is white precipitate. So solution X contain barium, and solution Y, because when you add acid to a carbonate, you will get bubbles, colorless gas. So what is the right answer? So solution Y is giving a bubbles, colorless gas. So A is the right answer. The colorless gas is carbon dioxide. And the previous one, because carbon dioxide is colorless, hydrogen is colorless, oxygen is also colorless. But how I can make sure? Because the options include the chloride salt does not give any gas when reacted with acid. So I'm left with only two right options. Either A can be answer or C. But because it is giving a white precipitate, so A is the correct one. Chloride or nitrate salt does not release the gas. How I know it is barium? Why not copper? Or because you can see copper and iron. If copper and iron salts are formed, they should form a colored salt, like a specific color should be there. But because it is not having any specific color, it's white in color, so it shows it can be barium or calcium. And I identify that solution Y is giving a gas. So when we add acid to a carbonate salt, then only it releases a gas directly. So it confirmed that A is a right answer. Otherwise, if copper and iron was there, then this should not be white precipitate. It should have a specific color. And in septium, atomic number 117 is a man-made element because artificial element. And that is below astatine in the group 7. What is the expected state at room temperature for this element? So as we go down, the state changes gas to liquid and then to solid. So if astatine is solid, then it should also be solid. Question 36. What could be the right answer for question 36? Yeah, that's right. A is the right correct answer. The reactivity decreases, so it's less reactive. The melting point increases, and the color will get darker. A period of a periodic table is shown. Group 1, 2, 3 elements are shown here. The group 1 to sub 8 elements are shown. The letters are not their chemical symbols. Which statement is correct? Metal and non-metal react to form an ionic compound. Look, element R does not conduct electricity. That's wrong because first three are the metals. So that's wrong. It can conduct. R and Y, metal and non-metal, will react to form an ionic compound. That's true. Element Z exists as a diatomic. That's wrong. Why? Because it's an unreactive metal. It only exists as monoatomic. And element Z react, so it is unreactive because of complete shell. It does not react. Question 48. The equation shows the reaction between halogen and aqueous bromide. So what could be halogen X and what are the colors? The more reactive halogen can displace the less reactive halogen from its compound. So this X should be more reactive halogen, example chlorine. And what is the appearance of chloride, bromide, iodide? These ions in the aqueous solution are colorless. And so the first one is chlorine. This is colorless and bromine is brown. Or if it is formed in aqueous solution, then it will be orange. When chlorine gas is bubbled through an aqueous solution of potassium iodide, a redox reaction. Redox reaction means, the term redox means oxidation and reduction both happen. That's called redox reaction. And what's the meaning of oxidation and reduction? Means there's a loss and gain of electron. So when iodide ion react with chlorine molecule, it form iodine molecule and chloride ion. State the color change expected in this reaction. So what will be the starting color? Because we have a solution of potassium iodide. So starting is colorless. Because why colorless? It's a iodide ion or potassium iodide solution. If it was iodine molecule, then you will mention, but starting color, it will be colorless. It's a solution. And as a result, iodine is formed in the solution, iodine molecule in the solution. So end color will be yellow if it is dilute, and it will be brown. Because iodine at room temperature, it is solid and its appearance is purple or black. But because this iodine is formed in the solution, that's why black or purple is not acceptable. Because the iodine is not forming iodine crystals, it is forming iodine solution. So iodine solution is not black or purple. If it is dilute, it will be yellow, and if greater amount of iodine, then it will be brown in color. Okay, in this question, the elements in group 7 are known as halogens. Some halogen react with aqueous solution halide. Complete the table by adding a tick to indicate when the reaction occur and cross to indicate when no reaction. You can use the screen annotation to complete this table. Use cross and tick. So chlorine with potassium iodide. Chlorine with potassium iodide. Chlorine is more reactive, so yes, it will react. That's true. Then bromine with potassium chloride, because it is less reactive, so it won't react. Bromine with aqueous, there's no reaction. Bromine with iodine, yes, there will be reaction. Iodine with chlorine, potassium chloride, no reaction, no reaction. So that's right. Write a chemical equation for reaction between chlorine and potassium bromide. So chemical equation, we have chlorine is reacting with potassium bromide. So chlorine is more reactive, it will displace bromine. It will form potassium chloride plus bromine. And the equation must be balanced. So this is a balanced equation. Astatine is at the bottom of group 7. Use your knowledge of the properties of halogen. Predict the physical state. Use the screen annotation. Okay, you can mention there. Solid, I will write. So it is solid. Then write a chemical equation for reaction between sodium and astatine. So sodium, metal and non-metal reaction is there. So sodium is Na. Astatine symbol is At. But how astatine exists? Because it's a group 7, so exists as a diatomic. But when it form a product, it will be sodium acetate So NaAT. And then the balance equation, I will put 2. So equation is balanced. A student bubble chlorine gas into a test tube contain aqueous potassium bromide. Describe the color change seen in the test tube. What a student will see when he's passing a chlorine gas through a aqueous potassium bromide. So because originally in a test tube we have aqueous potassium bromide, so its starting color, it's colorless. Group 1, 2, 3 compounds, they all are colorless compounds as in a solution, dissolved. And as a result, because it will form, as a result, it will form bromine. So orange, acceptable. Orange is brown, red, brown. These colors are acceptable. But bromine water, normally bromine water is orange in color. This is a true color is orange. Acceptable answer is red, brown. Then we have to complete the equation, chlorine reacting with bromide ion. So chlorine will displace this bromide ion. It will form chloride ion because you want to write an ionic equation. So how to write an ionic equation? The simple thing, you can write a word equation and then complete ionic. So sodium is reacting with potassium bromide, aqueous potassium bromide. Sorry, chlorine is reacting with aqueous potassium bromide. This result in a formation of potassium chloride plus bromine. The balance equation and state chlorine is gas, potassium bromide aqueous, potassium chloride also aqueous, and bromine is aqueous here, dissolved in water. We cancel out the common ions. So what are the common ions we have? We have potassium ion common, so we cancel out. So what we are left with, 2 chlorine, 2 bromide ion, result in a formation of 2 chloride ion plus bromine molecule. Is it clear? So you just have to complete the word equation and then yes, Cl2 plus 2Br minus gives 2Cl minus plus Br2. Then we have a noble gases or group 8. Group 8 elements, because they have complete or outer shell complete, so they're unreactive. So you can see how they're existing. Group 8, also known as zero group. They're unreactive and existing as a monoatomic gases. So helium, neon, argon, xenon, these all are monoatomic gases. And what are the uses? You have to learn the uses for helium, neon, and argon. So helium, where we use helium, it is used for filling for weather balloons. One reason is because it is less denser, So it can float. And the second reason, it is unreactive or non-flammable. Like first, these weather balloons, they used to fill up with hydrogen. Hydrogen is lighter than air. Helium is also lighter than air. Both of them are lighter than air. So balloon will rise in atmosphere. But what is the reason why the hydrogen is replaced by helium? Because hydrogen is flammable gas. It is reactive. It can react. But helium is unreactive, does not react. So the reason why the hydrogen is replaced by helium, because of its inert nature or unreactive nature. Where we use neon, it is used in advertisement, signs, bulbs, lamps. You may have seen these, like different colors lamps are there. It is filled with neon. And argon, krypton, xenon can be used. Where we can use for a filament lamp. A filament lamp, now a filament lamp is not used because of its efficiency. It's not very commonly used. It consists of a metal wire, a tungsten wire, and this tungsten wire is inside a glass. A metal wire, metal tungsten is there, and inside the glass. So why this region inside the glass, it is filled with argon, krypton, or xenon? Why not air? Because what happened when we pass the current through this tungsten, it's produce heat and light and start to glow. So when this tungsten start to glow, its temperature rises, temperature increase. So if it was filled with air, not argon, if air was there, air contain oxygen, and oxygen can react with this tungsten. So it will reduce the strength of the tungsten. It will turn into tungsten oxide, which reduce the strength of this tungsten, and the filament will break or melt easily. That's why we don't fill this filament lamp with air, we filled with argon. Reason why argon? Because it is unreactive, so even the temperature is so high, it will not react with the tungsten, and the filament will last for a longer period of a time. Is it clear? When it will form tungsten oxide, what will happen? Because the tungsten oxide, it will reduce the strength. So the wire, what happened? The wire will break. As the wire will break, the circuit is disconnected, so it will not glow or it will not light up. Then the last one, the last part of this, the transition element or the transition metal. So they are less reactive, they're harder. These are also known as typical metals used to make even jewelry or ornament. What are the comparison? When we compare the transition metal with other substances, transition metals with group 1, when we compare the physical properties, transition metals are much harder because group 1 or alkali metals, using a knife you can cut alkali metals, but transition metals are harder. High tensile strength means you need a greater amount of force to break them. That's called a tensile strength. Like greater amount of force is required to deform them or change their shape, size, or length. High density compared to group 1 or alkali metals, so they always sink when you place them into a container filled with water. High melting and the boiling point, and many of their compounds are colored. So to identify whether a substance is a transition element or a compound contain a transition element, this is one qualitative analysis using this. Like if I find that the substance is a colored, so this gives us an idea that there might be a transition element present. If it is a white solid, then it shows that there might be group 1, 2, or 3 element is present. When we compare the chemical properties, they are less reactive. The transition element, you will find the transition element between group 2 and 3. This position. So group 1, you have to learn properties. Group 7, you have to learn properties. Group 8, only the uses you have to learn. Not all our gases, all exist as monoatomic and the uses. And now we are discussing this part, the transition elements. So these transition elements, they have, when we are comparing their properties, physical and chemical. So the chemical properties, they are less reactive as compared to group 1 or alkali metals. They resist corrosion, does not rust easily. They show variable valencies or variable oxidation state. As you can see, iron can be +2 or iron can be +3. And they form colored compounds and can be used as a catalyst. Catalyst means a substance which speed up the reaction. And some of them are magnetic, like iron is magnetic, cobalt is magnetic, nickel is magnetic. Is it clear the comparison of the properties between the group 1? Sometimes they ask compare the physical properties of transition element with group 1, and sometimes the chemical properties of transition element, so or transition metal with alkali metal or group 1. Any doubt in this part? So in this question, which of the following could be transition element? They should have high melting point, they should have high density, colored, and conduct electricity. So what could be the answer here for question 3? They should, it's not about the highest melting point. Look, when the melting point is about 1900, that is considered as high, like 1000, 1200. So these two are high. Both of them are high. Refer, like, because it's not necessary that very high. It's 1200, 1400, 1600. These are refers to high temperature, high melting point. Then they should have high density. So high density, when you check the high melting point, these two are high, but high density, colored compound, gray or black, both are colored. But why specifically C is the answer? Because D is actually, it's a very high temperature. Like it's, you will find for diamond, the melting point of diamond in this order. It's very high temperature. It's about 1600, 1800, 1200. These are all refers to high temperatures.